Okay, study guide video to help you out. This -5 is evaluating being plugged in and showing the math. So I write that as F, where that X is. I put the -5 to show the number that I'm plugging in. For 2, I leave that alone, but next to it, I put -5, replace that X right there, and that's where I start to do my math. 2 times -5 gives me -10, and then that -10 take away 1 shows me that when I plug in -5 for X, I get -11 for Y, or F of X. For this one, I'm plugging in -6 into a fraction. So I have that fraction that's already negative. I write this as R, where that T is. I put that -6, and then I have that negative fraction, that -1/2, where that T used to be. That's where I put -6, and then I have that -6. And for this, you could do it a couple ways. You could take half of 6 and then times in 2 negatives and get +3. You could do it that way. You could take that -6 over 1 and times straight across and get -6 over -2 to get 3 that way. You could cross cancel. You could divide this by 2 and divide this by 2 and times those across and get +3. But no matter what, this timesing gives me +3, -6 over -2, or I could write that as 3 minus 6. So that gives me R of -6 equals -3. All right, this one, plugging in D, following order of operations. Show this as C of that D number 3, excuse me, equals 15 minus 4, and then where that D is, that's where I put another 3, and I times before I multiply this before I do my adding or subtracting. So that gives me 15 minus 12, or C of 3 equals 15 minus 12 equals 3. All right, next one gives me S of that 5 number. Make sure I write this as -12 plus 4, and I'm putting in the 5 right here, which gives me -12 plus 20, which is S of 5 equals 8. Moving on, number 5. This one, graphing using X and Y intercepts only. So for this one, my y-intercept is +9. That's my first number. And then I could use this number in front of X, this -3, and write it as a fraction. That's my slope. So that -3 written as a fraction tells me where to go from that blue dot. So right 1, down 3. But remember, they want you to plot only the X and Y intercepts. So right 1, down 3. Right 1, down 3. That's where I'm going to put my last dot. I'm going to make sure that I get rid of all these other dots. And again, I'll try to show you that slope pattern that I did right there. So that took me from that blue dot, right 1, and then from there I went down 3 because it's negative. And normally I would put a dot there, but because this one is having me, after I do this, it wants me to only plot the X and Y intercepts. So I'm going to make sure all of that stuff is gone and only my 2 dots are drawn. So with my line drawn through those 2 and putting arrows on my line, and now they want you to find the intercept coordinates. So remember, this y-intercept always the x number is 0 for the y-intercept. And then whatever that other number is, that 9, that is the y-intercept. For my x-intercept, the y number is always 0. Remember that. For the x-intercept, the y number is 0, and that 3 finishes up that coordinate. So x-intercept would be 3, 0. The y-intercept would be 0, 9. All right, this one, -6 is my y-intercept. So for this one, I'm starting way down at the bottom. All right, for this slope, which is +2, written as a fraction, shows me from that blue dot, every time I go right 1 dot, I go up 2 grids. Right 1, up 2. Right 1, up 2. That's where my next dot is going to go. And then make sure I get rid of all my other dots if I've drawn them, because they only want the x and the y intercepts. So if I draw only my x and y intercepts going right 1 up 2, right 1 up 2, right 1 up 2, I'm going to have it cross the y-axis right there at 3, 0 again. And then I draw a line through those, nice and long. Don't make it short. My arrows on each side of my line. Now I need to, write my coordinates. So my coordinates for the y-intercept, where x is always 0, is 0, 9. My intercept for the x, where the y number is always 0, is 3, 0. So that is 3, 0 for my x-intercept. And then, I'm sorry, this isn't 0, 9. This is going to be 0, -6. So let's get rid of that. This one is 0 for x, -6 for y. I'm not sure why I wrote that 9 right there. But there it is, 3, 0, and then 0, -6, where it touches the y-axis. All right, moving on. Number 7, graphing this and finding the solution point. So for this one, starting at -5, and then using this number in front of x, which is 1, telling me where to go from that -5, tells me right 1, up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1, up 1. Be able to stair step the opposite way. Left 1, down 1, left 1, down 1, left 1, down 1. Be able to draw a nice, neat, straight line through those dots. And I'm going to do the next one in blue, and we're going to see where those two lines come together, where they touch. That is going to be my solution point. And then the way I graph, always draw it long, always put arrows on either side to show that's going on forever. All right, next one in blue. This one's starting at -3. And from that -3, this one's rate of change or slope being -2 tells me every time I go right 1, I'm going down 2. Right 1, down 2. Which goes right 1, down 2. That's where my next dot goes. Right 1, down 2. Right 1, down 2. Be able to stair step the opposite way. Left 1, up 2. Left 1, up 2. Always stair step opposite direction. And if I draw my nice, neat blue line through those, and I see where those two lines intersect approximately, hopefully I get that. I'm thinking it's about the halfway point right there. So I'm thinking that solution point where these two touch, do that black. I would say using half coordinates, that's about 1/2 to the right for x, and then about down -4 1/2. or if I wrote that as a decimal, that would be 0.5 and then negative 4.5. All right, looking at this next one. Starting at positive 4, using this negative 1 rate of change number, the slope number in front of that x tells me right 1, down 1, right 1, down 1. Be able to stair step left 1, up 1, left 1, up 1. Draw nice, neat, long line through those points. Use a straight edge if you need it. Put arrows on either end. All right, now do my line in blue. Starting at negative 3. And this one, 1 over 2 tells me right 2, up 1, right 2, up 1, right 2, up 1. That's what 1/2 is. Right 2, up 1, right 2, up 1. Stair step down 1, left 2. Be able to stair step the opposite direction. Draw a nice, neat straight line through those coordinates or those dots best you can. Put arrows on either end of that line to show that that line is continuous and going on forever. And now using my eyeball here, I can see that's about another halfway spot I'm going to be saying. So this one, to me, written fraction form is 4 1/2, and then down negative 1/2 for my x and my y number. If I wrote that as a decimal, that looks like about 4.5 and then negative 0.5, approximately. All right, moving on. Number 9, looking at where my graph is increasing. That's going uphill from left to right. Those are my uphill sections. And I use the x-axis numbers to kind of describe where that starts. So between negative 9 and negative 6 going uphill, from negative 6 to negative 4 going uphill, that's where I'm getting these boundary numbers for my intervals. So if I'm looking at my answers there, my choices, first one says from 1 to 9. That's from here to here, and I can see it's not going uphill between those 2 points, so that one's no good. Between negative 9 and all the way over to 4, I could say no, because at this stretch it's going downhill, so that one is no good from negative 9 to 4. So let's cross that one out. If I look at from negative 9 to negative 4, I got one stretch going uphill, so I'm going to say yes, that is good. And then from negative 6 to negative 4, that's describing that little stretch by itself, so that one's good. All right, next it says, where's my graph decreasing? That's going downhill from left to right, looking at those same x-axis numbers. So downhill from left to right. Those are my 2 decreasing sections, starting from this negative 4 to this 1, and then get steeper from that 1 to this 5. Those are the 2 downhill sections. That's where I'm getting these numbers where it's going downhill. And then I could see another downhill spot from 5 to 9. So those are all downhill sections, all the way from negative 4 all the way to 9. It's going downhill. So if I look at these, from negative 1 to 9 going downhill, yes, that is true. From 4 positive to 9 going downhill, yes, that is true. From negative 4 to 9 going downhill, I can see that whole stretch going downhill. I would say that is true. And then from 1 to 9 going downhill, that is true. So all of those apply. So best answer, I would say the one from -4 all the way to 9, the one that describes it all the way. And the top one from -9 to 4. But I'm thinking for the exam, they want you to choose all the correct answers. All right, so here we go. Next, maximum. That's that top point. So this is saying at 4, 8. So if I go to 4, 8, that's right here saying this is the maximum, and I can see there's no data up there. This one says minimum, which is the low point, minimum at +9, -4. And I could see right there, that is that coordinate. That is 9, -4 for X and Y. So I could see that is true. That one's good. This one says a minimum at -4, +9, which is up here. And that's no good because that point right here at -4, 9, that's the maximum. But since this doesn't say maximum, that says minimum, that's no good. All right, moving on. For this guy, all my increasing sections. So increasing, I got from here to here, going uphill from left to right, using the x-axis to describe those uphill sections from 3 to 5, 5 to 7. So if I look at all of those that apply, -3, that's not good. That's way to the left here. This one says from -7 to 8. And again, that's way over here. So that one is no good. From 3 to 7, that one looks money. And then from 5 to 7, that one is good. If I had to choose a best answer, I would say the one that describes that whole uphill section. But on the final, you're choosing all correct answers. All right, so for this guy, which way or where is the graph decreasing? So from there, they're going downhill using -9, -4, and -1 to match where those numbers. So from -7 to +1, I could see that's not a stretch where it's all going downhill. From -9 to -1, I could see, yes, it is going downhill. From -9 to +1, nope. From 1 to 9, and I could say no on that one also. All right, this one says a maximum at 7, 8. So right 7 up 8, and I could see that does match this point. That is 7, 8. That is the maximum. This one says there's a maximum at 8, 7. So if I go right 8 up 7, that does not match that part of the graph. So that one's no good. This one says minimum at -7, -1, and I can see there's lower parts of my data, so that's not good. All right, moving on. This one, it wants domain. Domain is measured left to right using the X numbers. Range is measured from bottom to top using the Y numbers. So if I look at my domain here, this, because of this arrow, is going off to -infinity, going to the left. My right side here, because this open arrow, this little open circle, that's rounded. So for my domain would be rounded, always on infinity, -infinity to 7 rounded. My range for my bottom here from 1, and because this is closed, I write that square all the way up. And now, even though this is open, I do have data there, so we're going to consider that all the way. And then up is +infinity, so we'll say from 1 square to +infinity rounded. All right, this one. my domain from left to right. So it looks like I have a square bracket on this -6 all the way to infinity going to the right, so that's positive infinity. Some people, they think because it's going down it's negative infinity, but that's not true. Domain is measured left to right, and that's going to the right, positive infinity. My range, because range is measured from bottom to top, going down does mean it's negative infinity. All the way up here to the top, that's 5, and that's going to be square on that 5. All right, moving on. I think I did all of those. 11, 12. All right, solving these. Taking this and distributing. So this gives me -6x minus 10 plus this 10x equals 2x minus 16. I'm going to combine my like terms. That's going to give me -4x minus 10. And now it's a variables on both sides equation. So I'm just going to check something here real fast. All right, as I continue now, it's a variables on both sides. So I start on the left. I get rid of the plain number on the left by adding 10 to both sides. And then when that's gone, I'm going to stay on the right and get rid of that 2x. So that gives me -4x equals 2x minus 6. I'm going to stay on that right side and get rid of that 2x by subtracting. So -2x. That combines to give me -6x. And then now my last step on these variables on both sides, the opposite of timesing by -6, dividing by -6. And that gives me the solution x equals +1. So distributing -2 times 3, -2 times 5, combining -6 and +10. All these negative rules, adding 10 to -16, taken away. All right, this guy, solving, taking away 5, gives me 4x less than or equal to 44. Opposite timesing by 4, dividing, gives me x is less than or equal to 11. All right, for this variables on both sides, start on the left, get rid of the plain number on the left. When that's gone, I'm going to get rid of the variable on the right. So first step, get rid of the plain number on the left, know my negative rules. Second step, get rid of the number on the right with the x term, get rid of the x term on the right. This gives me -2x. And for this problem right here, if you remember, if you divide by a -2, that step right there switches my inequality. So my inequality, when that divides out, it's not x is less than, it switches to x is more than, and then that will give me +7. X is more than 7. All right, not less than anymore. All right, next, moving on. This guy, distributing. This gives me 6x minus 8 equals 5 minus 6x plus 3. Now I'm going to combine like terms. I'm going to combine these three numbers. I'm going to combine these two x terms. So when I do that, that gives me 6x minus 8 equals -2x. 5 plus 3 is 8. 8 minus 5 gives me 3. So my final number there is +3. Now it's a variables on both sides. Start by getting rid of the plain number on the left by doing the opposite, adding that 8. That gives me 6x equal negative 2x plus 11. Stay on that right side. Do the opposite of minus 2x, which is adding 2x. That will give me 8x equals 11. And then to keep my work vertical here, to show you on the side, the opposite of timesing by 8, dividing by 8. So that gives me x equals 11 over 8. Or if you unmix that, x, I believe, is 1 3/8. All right, here we go. This guy, I would, if I was you, flip this guy around. Not many people like solving it as is. So I would take that negative 3x and that minus 4. I'd write it on the left side. Make sure the little tip is pointing towards that stuff. Make sure the opening here is open towards that 5 to keep it accurate. And now solve that two-step inequality. So for this one, I'm adding that 4. I'm going to make sure I bring down that negative 3x. Gives me less than 9. And then right here, because the opposite of timesing by negative 3, I'm dividing by negative 3. That gives me x. And it's not less than anymore. It switches to more than. And then that gives me negative 3. So make sure you're okay with that switch. This makes it switch, dividing or multiplying by a negative number. All right, moving on. This guy, take away 7. Make sure I bring down that negative with the 6x. 49 minus 7 is 42. And then right here, it looks like you're plussing, but that's the opposite of timesing by negative 6, dividing. Inequality switches to this direction, less than or equal to, and then 42 divided by negative 6 is negative 7. So switches to less than or equal to. All right, moving on. For these, I'm solving for the letter M. So if I was you, again, I would flip these around. So I'm going to write this as 4m minus 30 equals k, to get it looking like a two-step equation, where the first step, adding that 30, bring down this 4k or 4m equal, and then k plus 30. Since I don't know what k is, I just write k plus 30. And now, just like I would a two-step equation, my last step is dividing both pieces by 4. And since that 30 over 4 doesn't reduce, I'm going to leave that as m equals k over 4 plus 30 over 4. That is my answer for m. Or if I wrote it like this, m equals k over 4 plus 30 over 4. I can't reduce 30 over 4 without getting a decimal. All right, next one. Flip this around. So this is negative 2t equals d. And then I'm going to take away this 6 and then divide by negative 2. So that gives me negative 2t. I write this as capital D minus 6. And now the opposite of timesing by negative 2, dividing by negative 2, dividing everything by negative 2, makes this t all by itself and gives me negative d over 2. I'll probably write it. And then this negative 6 and negative 2 right there, that combines to give me positive 3. All right, these guys, looking at my x numbers, those are my input numbers. If they do not repeat, it's a function. So none of these x numbers is the same. That means it's a function. Doesn't matter what the other numbers are. The next one, my x numbers, they all repeat. They're all the same. That breaks the function rule. Can't have an input give you two different outputs. This one, all my x numbers, they are different. -4 and 4 are not the same. So this is a function. None of those x numbers repeats. It's a function. And then I look at this guy. I have my x number show up twice, and it's given me two different y numbers. That's breaking the function rule. So they need you to explain in a complete sentence which one. I'm going to pick D. I'm going to say choice D is not a function because a x value gives two different y values. And then maybe write those two coordinates to show me what I'm talking about. So 5, -1, and then that same 5 and 0, that's breaking the function rule. Can't have the same x number give you two different y numbers. All right, moving on. More of those. So these x numbers, these are my input numbers. If none of those repeat, that's a function. And I believe on these, she's having you select one that's not a function. All right, so that one's a function. If I look at this, seconds and distance, the way we set up our graphs, our x-axis, that's going to be our time. So these are my x numbers. My distance for our graph, that's going to be my y number. So for this one, my distance, those are the y numbers. So for this, I'm looking at all these x numbers. If none of these repeat, I know it's a function. So none of these repeats, that's a function. It doesn't matter that those bottom numbers are all 7. Those are the y numbers. Those are the output numbers. What matters are the input numbers. None of those repeated. So for this table, this input-output table, these numbers are the x numbers. These are the y numbers. And if I look at number 3 right here, 3 has 2 arrows shooting out of it. So that's showing that 1 3 is given a 2 and another 3 is given a 4. That cannot be. That is not a function. So if I say, explain which one is not, I would say choice B is not a function because a x value gives two different y values. And then period at the end of that sentence, and then maybe show me what I mean, or show me what you mean. That 3 2 and that 3 4 cannot have the same x number give you two different y numbers. That breaks the input-output rule. All right, moving on. 23, domain. Domain are all my x numbers. This is my x-axis, all the x numbers for these dots. So that first x number, 1. The second x number, 4. Third x number is 7. We just want you to list the 4 x numbers from those coordinates. 1, 4, 7, 10. For this guy, list the coordinates. I got 1 for this coordinate. This is 1. This one is 3. Next one is 5. Then I have 7, and then another one, 9. My X numbers. Range are my Y numbers. That's range, but I'm not asking for range. I'm asking for domain. All right, moving on. For these guys, which one shows the domain of one rounded positive infinity? So I'm looking for a rounded or open circle and then an arrow to the right. So if I look at these choices here, this one starts rounded at that 1 and the arrow going to the right, which is positive infinity. So yes, this would be 1, infinity rounded. So this one right away is good. If I look at the one underneath it, this is rounded on 0 going to positive infinity. So since that's 0 there, I cannot choose that one. That one's no good. If I look at this guy, this one's starting at square bracket 0 to positive infinity. And since I'm looking for open round, and this is square, this is no good. All right, looking at this guy, I got another one here open, but no arrow. This is a closed dot, so that would be 9 square. That does not have an arrow. That's not going off to infinity. If I look at this guy right here, this one is rounded on the 1 to 11, another rounded because of that. And again, that does not match that 1 infinity. All right, moving on. This one, continuous means no dots. Discrete is dots. So these have dots. So that means this is discrete. Continuous is no dots, a line. All right, increasing or decreasing. This one, since it's going downhill from left to right, that is decreasing, downhill. Increasing would be going uphill. This is increasing. So since it's not going uphill, it's not increasing. Since there's no dots, no line, it's not continuous. Now my shape, exponential, is a curve. And since this is curving, I say exponential. Linear is a straight line. Since this is not straight, I don't pick linear. So discrete for dots, decreasing going downhill, exponential curved. All right, look at this guy. Continuous, yes. There's a line drawn through the dots, no dots. Dots would be discrete. Increasing, yes, this is going uphill. Increasing. Decreasing is when it's going downhill. So that would not be decreasing. Exponential is curved, and this line is straight. So linear is straight. This is a straight line, so linear. So continuous, increasing, linear. All right, moving on. This guy, if I look at these numbers, I could see that this is a big letdown here. It looks like I'm dividing by 3, or another way, timesing by 1/3. So 18 timesing 1/3 to get 6. It's going to be one of these curvy exponential graphs, geometric. This guy right here looks like I'm adding +7, adding +7, adding +7, going from left to right. This is going to be a straight, eventually going up straight, arithmetic line, going up by 7, straight line. All right, moving on. This one, reading these and knowing what I'm looking at. So Stephanie's hair grows 1 inch every month. That's just adding by 1, adding by 1. That's going to be a straight line. That's going to be linear. If I look at this next one here, 3 miles on Monday. On Wednesday, he runs 2 miles. And then on Friday, he runs 5. I can see these are not going up or down by the same. Not the same. Since these are not the same, this is going to be in that neither category. All right, next, if I look at this, 600,000, 4%. As soon as I see that percent, that's eventually going to be one of these curvy. That's exponential. Here's another percent, 2%. Eventually going to be one of those exponential graphs. And then if I look at this, $500 every year going up by 500, going up by 500. That's going to be straight line, linear. All right, moving on. For these, again, here's how I'd like you to do it. Looking at these numbers right here, finding a pattern of big and small. So if I look at -3, -3 is bigger than -5. If I look at my number line here, -3 is closer to 0 than -4. So that -5 number, -5 is actually bigger than -3 is bigger than -5. It's closer to 0. So if I look to the right, next step, 4, this bottom number is still bigger than that top number. To the right, 5 is still bigger than 3. But at this next step here, my next step has now this top number is bigger. 0 is bigger than -1. As I go to the right, -4, that number is bigger than -6. As I go to the right, I have another switch where now my bigger number is on the bottom. And as I go to the right, that bottom number is still bigger. So what I'm doing is looking for a switch from bigger to smaller from these two numbers, these two columns. And then once I find that switch, I use these x-axis numbers to describe that interval where that switch happens. So between -1 and 0, and then in this stretch between 1 and 2. So if I look, the right choice that has -1 and 0 and 1 and 2 is this guy right here. All right, next one. This one has the top number of these two is bigger. So 7 is bigger than 3. 4 is bigger than 2. But then right here, there's my first switch. Now my bottom number is bigger. As I keep going, my bottom number is bigger. My bottom number is bigger. My bottom number is bigger. Then right here, my last switch, now this top number is bigger. And now I use those x-axis numbers to describe where that switch happened between -2 and -1. And these numbers between 2 and 3. So if I'm looking, the choice that has between -2 and -1 and 2 and 3 would be this guy right here. All right, hopefully this helps. There's always a chance I made a mistake, so take my work with a little grain of salt. Good luck.